Hey YouTube, this is another video about consciousness. Today, although I've not explicitly stated my position, I'm going to try and defend it. If you've seen a few of my other videos, you'll know that I'm kind of tinging on the functionalist emergence approach to consciousness, and Stuart Hameroff is a huge critic of such an approach, along with Roger Penrose. And today I'm going to point out the logical fallacies in their arguments against functionalism. Hope you enjoy it.
I think quantum physics is the key to consciousness. You know, going back to the Greeks, there's been this controversy between whether the brain produces consciousness or some part of consciousness is out in the universe that we access. And quantum physics allows us to sort of bridge that gap and actually favors being able to access parts of consciousness or the essential features of consciousness which are present in the universe.
So tell me, Stuart, what essential features of consciousness are there out there in the universe? And presuming that we are part of the universe, what exactly are we accessing here if we're no separate from it? Consciousness isn't an irreducible fundamental property of the universe. If we assume that, then we're straight down the road to dualism, first off.
Emergence is the idea that conscious experience emerges at sort of a high level of complexity. The brain, like many other systems, being sort of a hierarchy, and if you get complex enough up that hierarchy, voila, some new property emerges, like a storm, for example, a hurricane or a tornado is a pattern that emerges from simple elements, gas molecules, air molecules.
Functionalism and emergence isn't saying that we go higher up the hierarchy, because if that were the case, then we'd create an ultimate observer, a Cartesian understander of our thoughts. As you said with the tornado, there's no hierarchy as such, because that would lead to an infinite regress of problems.
The problem with that, I think, is that none of these other emergent phenomena are conscious. They don't have conscious experience. Moreover, there's no real prediction at what level of complexity consciousness might occur in the brain. And if that were the case, computers should be conscious already, or should be.
The reason functionalist explanations don't suppose that any of the parts that make up a conscious entity are conscious is because if we have consciousness in terms of the solution to the problem of consciousness, then we haven't solved anything. You can't have consciousness on both sides of the equation and expect to solve it. It's simple algebra. As for thinking that consciousness suddenly emerges at some fundamental level of complexity, that's rather a misconception as well. I mean, take for example either the ant colony or the tornado. Now, it doesn't matter how many ants that you've got. The ant colony arises through the operations that the ant carries, so it's more important what the ants are actually doing. Of course, you might need a certain level of complexity to be able to call it an ant colony as such, or you might need a certain amount of pressure through the air molecules to call it a tornado as such. But there's no definitive boundary of what is a tornado and what's just, you know, a gale. It's subjective. We define it in our own terms. There's no on-off binary position of consciousness either.
And plus the fact that that would take away any possibility of free will. It also wouldn't give us this property of binding, how we bind everything together into one sense of self or unity of consciousness, and how we transition from the pre-conscious or subconscious to consciousness itself. These problems, I think, suggest that there's something more to consciousness than being an emergent property of computation. The brain is more than a simple classical computer.
Okay, the first point that he makes, which is utterly wrong, is he starts off by assuming that we have free will and then bases his thesis on that. Secondly, he talks about transitioning from the pre-conscious to the fully conscious state like it was an on-off binary thing, and he says that the binding problem will never be solved by a functionalist approach. Well, I don't know if he's looked into global workspace theory or multiple drafts, but these seem to adequately answer the questions of the binding problem. And to suggest that there's something more than consciousness is to also tend towards the side of a fundamentalist or a dualist perspective.
so to make these predictions that when the brain reaches a certain level of computations equivalent to the brain, it should be conscious. Of course, then they'll hedge and say, well, no, it's not organized the same. They'll keep pushing the boundary back. But the first problem with that is that AI people, artificial intelligence people who make these predictions, assume that the brain works along the lines of the computer, in that the neurons of the brain and their connections, the synapses, are the fundamental units.
Look, Stuart, for the last time, we're not trying to ram computations together, just ram them in, and then eventually, boom, at some certain threshold, consciousness appears. It's not what we're trying to do, right? As you said with the tornado, it's not how many gas particles that you have, it's how they're interacting, and furthermore, there's no distinction between what we would call a tornado and a very strong quasi-tornado-like wind. And as for neural networks, they are not supposed to be exactly like neurons. They're supposed to be modeled on the neurons because they provide us with novel properties like distributed programming, like the ability to learn easily, and so on and so forth. It's not that we think that these neurons are an exact model of the neurons in our human brain. It's just that they provide a very sufficient model for which learning can occur, and so on and so on.
So these proteins, the native proteins, switch much faster than neurons. There's many, many more of them. Well, there's like 10 million within each cell, for example, switching in a nanosecond. So if we think of processing going down to that level, there's as much processing in one neuron at that level as there is in the whole brain, according to these AI-type estimates.
Okay, Stuart, you've actually contradicted yourself here. Before you said if functionalism was the correct approach, then computers should be or will soon be conscious, which now you said, well, the brain's more complex than that. I agree, your work on microtubules, fantastic. But it's a complete non sequitur, as you go on to explain right now.
The problem is that even if that were the case, even if we're doing 10 to the 27th operations per second, even if the microtubules are the fundamental computers of consciousness, that still doesn't tell us why we have experience, why we have an inner life.
Okay, so for those of you that don't know much about Hameroff, he teamed up with this quantum physicist called Roger Penrose, and together they worked on this quantum theory of mind, which suggested that the microtubules in the brain within each neuron existed in a quantum coherence where they could exchange information instantaneously. Now, I disagree with this principle based on philosophical grounds, but also on the grounds of quantum physics. To suppose that something at such a macro size could exist in quantum coherent states for any reasonable amount of time is literally just unthinkable. But let's just see what he has to say about it.
And Roger's book was based on the idea that that our minds, our conscious minds, do something that is beyond the realm of regular computation. He called it non-computable. And it's through Gödel's theorem, and it's mathematical and philosophical. And to be honest, I didn't really understand all those arguments. But my gut level was that he was right.
Well, Stuart, that's certainly some good grounding to base your arguments on. You just thought that he was right. Well, Gödel's theorem applies to any system. That is the system of our brains. It also applies to machines. There is no distinction where we can say Gödel's theorem will apply to this system, but not to this system, if the systems are functionally identical. So the argument really falls on its face. If you might know that if you actually understood what you were talking about.
Explain how we can have this non-computability, which is really another word for free will.
Yes, Stuart. Non-computability means that we have free will. By non-computability, I assume that you're referring to probabilistic quantum processes, which are no more free than deterministic processes. And from what you said before, I assume what you mean by free will is the ability to supervene the natural order. How does probability supervene the natural order? How can we have free will in a quantum system? There's a lot more problems with quantum theories of mind that I don't really have the time to go into, but I was more trying to defend the functionalist approach, which Hameroff seemed to straw man a little bit there.